Let's talk about this review. This review is 50 questions. Your test will be 20 multiple choice. All right, and let's just get started with this. There's might be more detail in the worked out version on Canvas. All right, but this is a different option for you. Okay, so on one, one, two, and three, you're just trying to figure out if this equation is linear. So how do you do that? You do that by looking at all of your exponents in the problem. And if the problem, as written, has an exponent no greater than one, then it is linear. If it's greater than one, it's not linear. It could be something, and we're not really concerned about what it could be. We just want to know if it's linear or not. So if you look at this first one, you don't really see an exponent. And if you don't see an exponent, it's one. So this first one is linear. The second one, the highest exponent is x squared, so it's non-linear. Same thing here on three. You don't see an exponent, but absolute value, if you know anything about the graph, it looks like this. It's a V. Okay, so that is not linear at all. So um, non-linear. Okay, for number four, and for several of these, I'm just solving. So I'm going to zoom in. Let's see, we're going to move the two to the other side because we're adding. We're going to subtract it. So it's going to be minus two. So that's going to be x equals negative 18. Right? Um, okay. On number five, we can do this thing called fraction busting. So instead of trying to find a common denominator, we take what would have been the common denominator and multiply the whole thing, each term. So 2 times a half. So what's half of 2? 1. And then 2 times x is 2x. 2 times 12 is 24. Right? Then you can work it simply without fractions. Right? So I'm going to take the 1, move it across. Because the 1 is positive on this side, to move it across, I got to subtract. Right? So it's going to be 2x equals 23. Right? I divide x equals 23 over 2. All right. All right. Same thing on number 6. I'll multiply by what would have been my common denominator. 18 doesn't go into 6, but 6 does go into 18. So I can multiply this entire thing by 18. And so that's going to be 18x. 6 goes into 18 three times, so it's going to be 3. And 18 goes into 18 one time, so it's going to be negative 1. Right? I'm going to move the 3 to the other side. That's going to be minus 3. That's going to be 18x equals negative 4. I'll divide that. Okay, so I'll divide that. That's going to be 18 there, 18 there. Cross that out. All right, I can reduce this. So x equals negative 4 over 18. Both of those are even. So I can take at least a 2 out. So let's start there. We got negative 2. And 2 goes into 2 goes into 4 2 times. 2 goes into 18 9 times. Okay, and I can't go any further. So that's my answer. Okay, again, 7, same process. What would have been my common denominator? All right, 5 and 6 are so close together that the thing that they're going to go into is 30. So multiply everything by 30. 6 goes into 35 times. That's a negative. So it's going to be negative 5 plus 30z equals 5 goes into 36 times. So there you go. I'm going to add 5 to both sides to move it. So it's going to be 30z equals 11. Okay, so when I divide, that's going to be z equals 11 over 30. All right. Normally, I would say we could do a similar process on number 8 that we did on 5, 6, and 7, where we got rid of fractions. We could also do a similar process to get rid of decimals, but this one is pretty straightforward. It would just complicate things to do that. So I'm going to do this, and 16.3 minus 7.9, that's going to be x equals 8.4. And I'm assuming that you're using a calculator here. So I'm not going to get bogged down in calculations because I believe you can do that. All right, when we get to 9, we do have a decimal, but again, to get rid of the decimal would complicate things too much because you see I have a 3y and a 2y. If I subtract, that's going to be y equals negative 5.9. Like, that was all. It would have complicated things too much to try to get rid of that decimal. So we will talk about that shortcut in just a little bit, but you need to be careful when you choose to implement said trick. All right. Now, when you see a number outside of parentheses like this, you just distribute, giving that number out front to everything inside. I'm going to take the 2, give it to everything here. So it's going to be 2y plus 14. 3 goes to everything. So that's going to be 3y minus 6. Okay, I'm going to try to keep my y's positive. So I'm going to move the 2y here. So it's minus 2y. It's going to leave me with 14 equals y minus 6. I'm going to add the 6 to the other side. Again, how do you know if you're adding or subtracting to one side or the other? What was the original sign? Um, here, 2y was positive, so I subtracted. Here, 6 is negative, so I'm going to add to both sides. Okay, so that's going to give me y equals positive 20. And that's how you do that. Okay, we're 1/5 of the way through, right? This is one of those situations where I'm expecting you to know how to calculate, right? You're going to clean everything up first. Clean everything up first. All right. So look, I have 4x and 5x. That's going to be 9x here. And then add up all your stuff. You got negative 8.2, negative 6.6, and negative 2.8. You add all that up, you get negative 17.6 equals. Right here, I just have 10x. So I don't have to do anything with that, but I do need to add the 5.7 to 1.4, and that's going to give you 7.1. Now, this looks very similar to what we've already been doing. And again, at this point, it would be too complicated to get rid of the decimals. So I'm going to move the 9 by subtraction. Means that we negative 17.6 equals x plus 7.1. And again, I say it would be too complicated to get rid of the decimal because you see here with one movement, I'm down to a single variable. Like I don't have to divide or anything. I just, within one movement, I've got my x. Now I just need to get it by itself. So I'm going to subtract negative 7.1. And so that's going to be x equals negative 24.7. Okay. Now, the monthly cost of a certain long distance service is given by this formula, where C is in dollars and T is in the amount of time and minutes called in a month. Find the cost of calling a long distance for 140 minutes. Because we're talking about 140 minutes, I'm plugging in for T. And so I'm going to C 0.07 times open parentheses 140, right? Close parentheses plus 4.95. And you could do this in pieces or in part. If you're using a calculator, I would just do the whole thing, plug it in as it looks, and hit enter. And that's going to be 14.75. What is that? Well, if you look back at the problem, it says C is in dollars, and that's your cost. Okay, so we're talking this is $14.75. Okay, so that's how much it costs for 140 minutes in long distance. Okay, 13 says the altitude above sea level on an airplane just after taking off from an airport on a high plateau is given by the formula here, right? Where h is in feet and t is in time in minutes since takeoff. Find the altitude of the airplane after 6 minutes. Okay, again, we're talking about 6 minutes. That's t, so I'm plugging in here. Right, so it's going to be h equals 1100, comma, or open parentheses 6 close parentheses plus 3160. Right, again, I expect you to be able to crunch these numbers in the calculator. That's going to be 9,760 feet. Don't forget your units. Okay. Now, we're still solving problems, but we're going to switch gears for a second. Right now, we're talking about multiplying and dividing mainly. Okay. So because this 4 is in the bottom, and I want to get n by itself, right? You currently have n divided by 4. I want to undo the division. And you undo division with multiplication. You undo multiplication with division. So here, I'm going to multiply by 4, multiply by 4, and so that's going to give me n equals 40, right? Because that goes away. N equals 40. And easy peasy, that's it. That's all we have to do for that one. Very similarly, all we have to do here is multiply by negative 5. That goes away. Multiply by negative 5 here. And I put parentheses in around it because I'm multiplying by a negative, and I want to make sure that I'm not going to make a sign error. Okay, so that's going to be v equals negative 10, and we're done. Starting out simple, it will get a little more complicated, so just hang on. All right, so I'm going to divide. On 16, I switch gears, and now I'm multiplying by a, and I need to undo that. And again, you undo multiplication by division. So I'm going to divide by negative 7. You have to take care of the negative as well as the number, so make sure you're taking account for that. So that's a equals negative 6, because 42 divided by 7 is 6, and I have a negative there to account for it, so the answer is going to be negative 6. All right, again, I'm going to divide negative 72, negative 72. Clearly, this is not going to come out nicely. I'm going to end up with some kind of fraction. So you need to ask yourself, they're both even, so I could divide by 2, but let's try a little harder. What is something that goes into 56 and 72, right? Well, I know that 7 times 8 is 56. I also know that 9 times 8 is 72. So it looks like 8 goes into both of these. So I can divide both of these by 8. Right? And when I do that, you're going to get 7 on top, 9 on the bottom. But remember, you're dividing by a negative 72, right? So you need a negative. And the negative could live in one of three places. And it can live in the top with the numerator, it can live in the bottom with the denominator, or it can live out front of the fraction, right? So it doesn't really matter. Uh, so, but you need to include the negative. Where you put it, as long as the fraction is simple, the negative can float and it's not wrong. It's only wrong if you forget the negative. Okay, now we have 18, we have to deal with the 6 and the 7. You can do this in 2 steps or 1 step, right? For the sake of time, I'm going to just do this in 1 step. And you can do that by multiplying by the reciprocal. And again, don't forget the negative. So that's going to be negative 7 over 6 times negative 7 over 6. Okay, and remember, this is over 1, right? So this is going to go away. That's going to go away, right? 6 goes into 6 one time. 6 goes into 24 4 times. And so when I multiply this, that's going to be x equals, right? I got negative 7 times 4. That's going to be negative 28. And that's how it's done. Now, I'll talk you through it. I'm not going to show it, but we'll talk you through it. If you want to do this in 2 steps, you can multiply by the 7 on both sides and then divide by the 6. And you can either deal with the negative when you multiply by 7 or when you divide by the negative 6. You just need to deal with it at some point, or you're going to have to do a whole third step. Okay? All right, moving on. All right, on 19, we're going to combine like terms first. So it's going to be 26x equals 17. And then you divide to get 26, or to get 26 away from the x. Yeah. Okay. 17 is prime. So if you don't know that, you can try to reduce. But again, I would always try to reduce in your calculator if you're not familiar with the numbers and you're not exactly sure if it's going to reduce or not. Try it. Use your calculator, make it work. Right. But 17 is prime. 17 is prime. That means nothing else will go into it except 1, and that means this thing is already simplified. Okay. All right. We got negative 8x plus 5 equals 85. Because of the positive 5, I'm going to move it over, and when I move it, I'm going to subtract it. Right. So it's going to be 80 equals negative 8x. Right. You're going to divide by negative 8. And so that's going to be x equals negative 10. Okay. All right. Technically, my x is on the right, but remember, if this is x equals negative 10 or x equals negative 10 this way, it's the same thing. So whichever direction you choose to write it, it's the correct way. Right. Okay. Now, typically, I try to keep my variable positive, but in this case, if I try to keep my variable positive, it's going to take me 2 steps to solve this thing, and it's just that seems like extra work. So I'm going to take the 10y and subtract it, which will result in a negative y, but I can handle it. It's going to be 49 equals negative 7y. Okay, and then you're going to divide by negative 7. Okay, so y equals negative 7. Well, 49 divided by 7 is 7, and then you have the negative, so the answer is negative 7. Okay, all right, here, you should always clean this up if they give you too many things on one side or the other or both. All right, so this is going to be negative 3x plus 2 equals negative 8x. Again, similar to the last time, it would just make more sense if I added the 3x to get my x's together quickly. All right, so it's going to be 2 equals negative 5x. You divide, and x equals negative 5 over 2. Or, you're doing this correctly, it's negative 2 over 5. Right? Almost messed that up. Hopefully you were paying attention. Okay, when we get to 23, this is one of those where we have to rewrite the words into an equation and potentially solve. Okay, so it says 30 is divided by a number. Anytime you see a number, think variable. Okay, in this case, it could be x, could be y, it could be any of the 26 letters of the alphabet. All right, but again, your test will be multiple choice, so that decision of what it will already be made for you. You just got to figure out which one matches. So 30 divided by x, 30 divided by some number, some variable is x equals 5. Now, we may or may not have talked about this already, but you can still do this. You need to get x out of the bottom before you get it by itself. So you're currently dividing by x. So how do you undo division? You multiply. So I'm going to multiply both sides by x, and that will allow me to get rid of that. And that will be 30 equals 5x. Now that looks more like what you're used to, right? And then I just divide. Okay, there you go. And that's going to be x equals 6. Okay. All right, a couple of word problems here. All right, the formula C, uh, this formula models the data for the uh, cost to produce X units of, uh, to produce X unit of products, where C is given in dollars. How many units can be produced for the cost of $425,000, 755. So because this is cost, I'm going to set that out here. 425, 755 equals this entire formula, 532 x plus 155. I'm going to subtract the 155. It's going to be 42, 425, 600. Divide by the 532. You should be fine working with bigger numbers because you have a calculator, right? You do that, and it's going to equal x equals 800 units. 800 units, right? So for that price, that's the cost of 800 units of product. Okay. Similar problem. This is the weekly production cost C of manufacturing X calendars is given by this formula, where the C is in dollars. What is the cost of 288 calendars? So this time, it's asking for the calendars itself, right? X is calendars. So this time I'm plugging into X right here. So C equals 292 plus 2 times 288, right? Crunch your numbers, right? And it's going to be 598. Again, we're asking about cost. So we interpret it to be $598 that it's going to cost to make that many calendars. Okay, we're at the halfway point, guys. Just hang in there. All right. Again, clean this up. Right. So 7 minus 4 minus 10. Right. -4, -10. That's -14. So 7 minus 14 is -7. Okay. Equals, and then this together is going to be 63. So -63. Negative divided by -7. Two negatives make a positive. So it's going to be x equals +9. Okay. Right. Here, I'm just going to distribute. So it's going to be 24x minus 6 equals 24. Because it's negative, I'm going to add to the other side. This is going to be 24x equals 30. Divide to get x by itself. All right, so that's going to be x equals 30 over 24. And I have to reduce. All right, so what goes into both of those? All right, 6 goes into both of those. So if I divide both of these by 6, all right, that's going to be 5 on top, 4 on the bottom. And now that is simplified. Check my signs. Everything looks good. 5/4. All right, moving on. 28. All right, this is going to be 12t. 4 times 18 is 72 minus 4 equals 44. Right? So clean this up. We got 12t minus 76 equals 44. I'm going to move this over here. So it's going to be plus 76. Right? So it's going to be 12t equals 120. Divide by 12. And you should get t equals 10. Isn't it nice when you get something that's kind of complicated, like 28 started or 29 started, and it comes out to something super simple? I don't know about you. I get satisfaction out of that. Right? 29. Again, just take a second. Just expand, distribute negatives as necessary to clean things up. So you got -43 minus 3y plus 1, right? Make sure you distribute the negative equals 3y minus 6 plus 3y. Okay. Over here, the 3 stops at the 2 because that's where the parentheses stops. All right, let's clean this up. All right, I got -3y. -43 plus 1 is going to be -42. 3y, excuse me, 3y and 3y is 6y minus 6. Okay. So let's do this. I'm going to add 3y. So -42 equals 9y minus 6. Add 6 to both sides. It's going to be 9y -36. So that's going to be y equals -4. Okay. 30. again, we're seeing fractions. So this is one of those times where I can bust out my fraction busting skills. I'm going to multiply everything by what would have been my common denominator. In this case, 5. Easy peasy. Right? So you got 5. 5 goes into 5 one time, so that's just 1f. There's no denominator on 3 or 1, so I'm just straight up multiplying. 5 times 3 is 15. 1 times 5 is 5. I'm going to add 15 to the other side. Add 15 to the other side. So it's going to be f equals 20. Easy peasy. All right. You're 3/5 of the way done, guys. Just hang in there. All right. 7 and 5, they go into 35. So I'll multiply that. All right. 7 goes into 35 5 times. 5 times x is 5x. 5 goes into 35 7 times. 7 times x is 7x. 7 goes into 35 5 times. 5 times 4 is 20. Right now, that looks like something that's much cleaner to use. That's going to be minus 7x. That's going to give me negative 2x equals 20 divided by negative 2. X equals negative 10. Okay. Now, you apply the same concept here. Looks like everything will go into 6, so I'm going to multiply everything by 6. Now, when I multiply the first one, luck out because I don't have to multiply anything up top. On the second one, 3 goes into 6 2 times. That means I have a 2 left to multiply the top. I'm not going to do that right now. I'm just going to write it. 2 times x minus 1 equals, and 6 goes into 6 one time, that's going to be 7. Right? Anytime you have something complex like this, you don't want to do too much at once. By multiplying everything by 6, I know I'm going to have to multiply. I get rid of my denominator with nothing left to multiply. The first one and the last one, but in the middle one, I have to still multiply by 2. So it's better for you to write that out and then multiply it in the next step than try to do too much at once. So it's going to be x plus 6 plus 2x minus 2 equals 7. All right, again, clean that up. So it's going to be 3x plus 4 equals 7. And it's going to be minus 4. So it's going to be 3x equals 3. And you can already see x equals 1. Okay. So again, it's very satisfying when something as complicated as this comes out to something really simple. Okay, I mentioned earlier that working with decimals, I can get rid of these very simply, similar to what I would do with fractions. All right, this has 2 decimal places, this has 2 decimal places, this has 2 decimal places. So that's the 10th place and the 100th place. So if I multiply by 100, I can move that decimal place 2 places to the right, which would be behind all these numbers. So this is exactly what I'm going to do. I'll multiply by 100, and that's going to result in 5y plus 11 times 200 minus y. I don't touch the parentheses, equals 44y. So now I'm through with all my decimals, and I'm going to distribute this. So 5y, 11 times 200 is 2200, minus 11y equals 44y. Clean this up. This is going to be negative 6y plus 2200 equals 44y. I'm going to add 6y to the other side. So it's going to be 2200 equals 50y. Divide by 50, you'll see that y equals 44. Okay. I think you would be more comfortable working with these bigger numbers, especially if a calculator, than working with those decimals. You still get the same answer if you work with the decimals straight up, but if you manipulate the problem to begin with to get rid of the decimals, all right, you have to deal with big numbers. It's a trade-off that you have to make. And I think most of you would choose to make that trade-off if it meant you didn't have to work with decimals. So just be careful. Just be mindful of that. All right, we'll do the same thing on 34. All right, we'll do the same thing on 34. Um, notice this one only has 1 decimal. You're still going to multiply by 100 because this one has 2 and this one has 2. You want to multiply by the biggest power of 10 that's going to get rid of all your decimals. So in this case, that's going to be 21, x plus 50. That's going to be 37, x plus 60 equals, remember, I'm moving the decimal place 2 places to the right. Use your calculator if you need help. All right, it's going to look like that. Okay. So again, it's okay to work with big numbers if it means you don't have to work with decimals. So using your calculator help you out. This is going to be 21x plus 1050 plus 37x plus 2220 equals negative 3, 3110. Okay, and this up 21 and 37. That's going to be 58x. 1050 and 2220. That's going to be 3270. So plus 3270. Can't do that in your head. I'm not expecting you to. You can use your calculator for that. Negative 3110. I'm going to subtract this over. Remember, I have both of my numbers have the same sign. So I'm going to add and keep the sign. So this is going to be 58x equals negative 6380. Divide. X equals negative 110. Okay, right? Right, so we have 18x here plus 18 equals 18x plus 12 plus 6. All right, so we're solving. We get 18x here plus 18 equals 18x plus 18. Now you have the same thing on the left as you do on the right. If you want to take one more step, so just check yourself. You got minus 18x here. That's going to result in 18 equals 18. When you see something like this where there's no x's left, and you ask yourself, is this a true statement? Does 18 in fact equal 18? Well, yes, it does. So this is going to be all real numbers. And you can write that one of two ways. You can say negative infinity to infinity, or you can spell it out, all real numbers. Both are correct. You just have to choose which way you want to write it. So 18 is a situation where I have infinitely many solutions because I ended with a true statement. Okay. Page 3 is the last page. So we're on the last page here. Let's take a look at number 36. All right, so we got 36, 3x plus 3 plus 5 equals 3x plus 2. Clean this up. You got 3x plus 8 equals 3x plus 2. Now, you should be able to see it already. I have 3x and 3x, which is not going to change anything. But the plus 8, the plus 2, those are my differences. Because they're different, as soon as I move this, all right, that means it's going to equal 8 equals 2. Again, you ask yourself, is that a true statement or not? In this case, 8 does not equal 2. 2 does not equal 8. So this is an example of no solution. And you can write that 0 with a line through it, or again, you can spell it out. Okay. So on 35, you had an example of a true statement. Everything, my x's fell out, and I was left with a true statement. On 36, my x's fell out, and I was left with a false statement. And that's the difference between the two. Okay, 37. Be careful with these. All right. I'm not trying to get rid of my fractions right now, because if you look inside the parentheses, sorry, if you look inside the parentheses, I can take a fifth of 10. I can take a fifth of 15. I can take 6 and multiply it by 1/3 and get a whole number. I can take 6 and multiply it by a half and get a whole number. Okay. So what is 1/5 of 10? 5 goes into 10 how many times? 2. That's 2x. 5 goes into 15 how many times? 3. So that's 3. 6 times, or 3 goes into 6 how many times? 2. 2 times 1 is 2x, right? 2 goes into 6 3 times. So 3 times 1 is 3. And then you have the plus 5. All right. So you got 2x minus 3 equals 2x plus 2. All right. This is very similar to the one before. You may see it already. If not, I'm going to move the 2x and get rid of it. All right. So I'm going to leave me negative 3 equals positive 2. And just like before, this is a false statement. So just like before, my answer is no solution, which you can write one of two ways. All right. All right. Again, we're switching gears. Rewrite as an equation and solve. All right. So it says 3 times the number. Again, when you think number, think variable. So in this case, we're going to say x. All right. So this is going to be 3 times x. So 3x is added to negative 9. All right. And the result is equal to 12 times the number. It didn't say a different number, so we automatically use the same number. Okay, and remember, a plus and negative is the same thing as if I wrote 3x minus 9 equals 12x. Now, if you're comfortable going straight for the second line, straight from the wording, great. But I highly recommend, if you're not, just write it as it's written. It says it's added to negative 9. Sorry, it says added to negative 9. So it says added to negative 9. Okay, and so you could write it like that and then write it as 3x minus 9. Right? Either way, I'm going to move the 3x here. My subtraction is going to be negative 9 equals 9x. And so when I divide, I'm going to be left with x equals negative 1. Okay, 39 in one state. In one state, speeding fines are determined by the formula here, where F is the cost in dollars of the fine. If a person is caught driving X miles per hour, if the fine costs $295, how fast is the person driving? So because F is the cost in dollars, and I'm given dollars, I'm going to set this entire thing equal to $295. And I'm looking for how fast they were going. Now, I'm going to work this one in what you might consider a little unorthodox. All right, first of all, I'm not going to distribute. I'm going to go straight for the 75. I'm going to move it to the other side. Minus 75. That's going to result in 220 equals 10. Again, I'm not distributing because if you notice, if you look, 10 does go into 220. So I'm just going to divide. Right? I'm just going to divide. Get rid of that. Get rid of that. And so that's going to be 22 equals x minus 60. And I'm going to add that to both sides. So that means x equals 82, which means it's going 82 miles per hour. Okay? Now, from here to the end, we're dealing with inequalities. And so it shouldn't take as long to get through these. But inequalities are, remember, inequalities is if I have less than, greater than, that means I have parentheses. That means I have an open circle. If I have less than equal to, greater than equal to, that means I have brackets, which means I have a closed circle. And if I have negative infinity, positive infinity, it's always a parentheses. Because parentheses means I'm approaching this number. It doesn't mean equal. Brackets mean equal. Okay, with that said, let's move on. So I want to provide the interval notation and the graph. Okay, so x is less than or equal to 5. That means 5, I can't go any higher than. So that's going to be, you always write your interval least to greatest. So negative infinity, well, let's go the other direction because it may be simpler for you to do this. All right, so I'm going to do a 5. It says less than or equal to. Right, so that means I'm going to shade to the left. And because it's equal to, it's going to be a closed circle. All right, so once you have that, this makes it really simple to figure out what my uh, interval is supposed to be. Right, it's everything up to and including 5. So I got 5 on the high end and a decrease without bound. Okay, so I got my graph, I got my interval. Good. On 41, again, going for the graph, I got -6 on one side, -2 on the other. Both of them have the bar underneath the inequality. So that means I'm going to have a closed circle here, closed circle here, and a shade in between. Okay. Okay. So that should also mean that when I go to write my interval, I got -6, comma, -2. And because of both of them having a closed circle, it's going to be bracket on one side and bracket on the other. Okay. So there's that. Okay. Again, you got -17, uh, closed circle, shade, shade to the right. Okay, so that means -17 is the lowest end. It's included, and it's increasing without bound. Right? When the infinity is on the right side of the comma, it's positive. If it's on the left side of the comma, it's negative. So keep that in mind. So there's that. There's that. And we keep going. Here, right, we got -12. It's an open circle. We're on shade to the left. All right. So that means -12 is the highest point. It's parentheses because it's open circle. And then I got negative infinity because it goes forever to the left. All right, so we're moving through this pretty quickly. 44. Okay. Here, I have to do a little work first. I'm going to do just like I would in an equation. I'm going to subtract the 9x. That's going to be x plus 2 less than or equal to 8. I'm going to move the 2 over by subtraction. That's going to be x is less than or equal to 6. So here, I'm just going to provide the graph. I've got the inequality. I'm going to do the graph. The inequality and the graph. I got the inequality. Time for the graph. I got 6, close circle, shade to the left. Okay. Now, remember that the whole purpose of the inequality and how helpful it is the bar tells you whether or not it's going to be open or closed. The direction it's pointing tells you where to shade. So this one's pointing to the left. That's why I shade to the left. Okay. And because of the bar, that's why it's closed. So the inequalities can be super helpful. Like over here, 41, X was in between those two numbers. So it told you exactly that I was going to be shading in between here. Okay. 45. Here, I divide by -2, and I have X is less than -20. Now, you'll notice that I changed my sign, and you do that anytime you multiply or divide by a negative. Doesn't matter, like if the negative was on the 40 and I just divided by 2, all would be fine. I wouldn't have to change the sign. But since I divided by a negative, I have to flip my inequality. Okay, so let's see, we got -20. It's less than 20, so I'm going to have open circle, and I'm shading to the left. Okay, I got my inequality, and I got my graph. Now, if you're still struggling to understand why we did the inequality sign change, then just ask yourself, what's a number that is greater than -20? Well, 0. So if I plug in 0 for x, that makes this entire left side 0. This entire left side 0 here. And is 0 greater than 40? No. All right, pick a number that is greater than, or sorry, less than -20. Let's say -25. All right, if I do -25, that's going to be +50, which means that's going to be greater than 40, which is true. So that kind of helps you understand why we're flipping the sign. Because if I don't, then the whole thing breaks down. Okay, we're so close, guys. All right, 6 minus 4, because I'm giving the 2 to that. All right, and then don't forget to give the -2 to the negative x. That's going to be plus 2x. Less than or equal to 14. All right, let's clean this up. We got 2 plus 2x. Less than or equal to 14. I'll move the 2 over here. Minus 2. 2x. Less than or equal to 12. Right? And so this is going to be x is less than or equal to 6. Okay, so I got 6 in the middle. It's closed circle because of the bar. Now shading to the left. Okay, easy peasy with the inequality and the graph. All right, 47. We can still do a fraction busting technique here. Instead of multiplying by two, okay, so let's pause. If I take the 2/3 and I multiply it into that parentheses, I end up with a fraction in the front and a fraction in the back, 4/3 and 2/3. Or I can multiply this entire thing by the reciprocal, which is 3/2. To do that, that means the 3's go away, the 2's go away. I can move that to the other side, right? And that's going to leave me with 2x minus 1 on this side, less than, and then that's going to be -6 times 3/2, which 2 goes into 6 3 times. 3 times 3 is 9, and it's negative, so it's going to be 2x minus 1 less than or equal to, or sorry, less than -9. I'm going to add the 1, so it's going to be 2x is less than -8. X is less than -4. Notice, I divided by a positive, so my sign didn't change. My inequality sign didn't change. Right? My answer, I was dividing into a -8, but it only matters if I'm dividing by a negative. So my sign didn't change. Again, if you're struggling with that, you can graph it and test it out. So I got -4, open circle, see to the left. Okay. So look, I have it's gonna be -4. So what's greater than -4? 0. So if I plug in 0, is 0 less than -4? Right? It may seem like a trick question, but no. 0 is actually bigger than -4 because it's -4 is to the left of 0. Right? 0 is over here. So it's not less than. Right? So keep an eye on that or be careful with that. Right? So you got your inequality, you got your graph. All right. Uh, all right. So 48. I got 88. 8x minus 7 greater than or equal to 7x. Uh, minus 7. I'm going to subtract 7x. All right, that's going to leave me with x minus 7 greater than or equal to -7. I'm going to add the 7. That's going to be x is greater than or equal to 0. Okay, x is greater than or equal to 0, which means same as before. 0, close circle, say to the right. Right? Take your time on 49. So this is going to be 8 plus 4x less than 6x, or excuse me, you have 6x minus 2x. It's going to be 4x. All right, you got 19 minus 11. It's going to be 8. All right, and we'll subtract the 4x. And that's going to be 8 is less than 8. Again, ask yourself, is this a true statement? Is 8 less than 8? Now, because of the inequalities and how they are, if this said less than or equal to, you could make an argument that it's, all right, then that would be a true statement because it's 8 is less than or equal to 8. And the equal to would take care of that. Because it's only less than, 8 is not less than 8. So this would be an example of no solution, which again, you can write 0 with a line through it or spell it out. Okay, all right, all right, last one. We're done. All right, Claire has received scores of 85, 88, 87, 90 on her algebra test. What is the minimum score she must receive on her fifth test to have an overall test score average of at least 87? Okay, so remember that an average is you add up all your items and you divide by the number of items. So I have 85 plus 88 plus 87 plus 90 plus some unknown grade for the fifth test. And then I divide all that by 5. And I need at least an 87. So ask yourself, is that less than, greater than, less than or equal to, greater than or equal to? Well, it says at least. So I can't have less than. I can't have an 87. I can also have more than 87. So that would be greater than or equal to 87. Now, if you add up 85, 88, 87, and 90, you get 350. That'd be 350 plus x. And if you take the 5 and multiply it to the other side, 5 times 87 is 435. Okay, and then I'm going to subtract minus 350, and that's going to give me x is greater than or equal to 85. So what is the minimum score she needs? She needs an 85. And that's your answer. Well, guys, it's been fun. I hope you stuck around, and I will see you in class.